In 21st century, the use of polymer concrete have been identified as the most innovative material to replace the conventional cement concrete. Polymer concrete is a monomer that are polymerized in situ in presence of other components. In situ polymerization can be take place by heat, catalyst or radiations. The monomer that have been polymerized can be used as a binder component where it does not require water to be set or hardened. The polymer concrete comprise of polymeric binder, hardness and well-graded aggregates. The interaction of these components are entirely depends on their physical and chemical reactions. Methyl methacrylates, unsaturated polyester resins, epoxy resin, furan resin, polyurethane resin, urea formaldehyde resins, and blend of styrenes are commonly explored as the polymer concrete resins. There are so many advantages of using polymer concrete, such as it boasts high mechanical strength, long durability, and resistance to chemical attack. However, the cost of polymer concrete can be 10 to 100 times compared to ordinary Portland cement concrete. That's why the commercializations and demands of the product is low compared to the other products. Hence, to overcome these problems, our group will be focusing on the use of polymer concrete as a brick material.
Okay, for the basic concept, wet polymer concrete was expensive because it used same raw material as conventional obvious concrete, where it is made of cement, fine aggregate, coarse aggregate, water, and polymeric resin like thermoset resin. This addition of polymeric resin will increase the strength of the polymer concrete, but it also increases the cost of this wet polymer concrete, and this is the reason why it's hard to be commercialized. So, in order to reduce the cost for polymer concrete, this polymer concrete has been modified into polymer brick. This polymer brick has the same strength as a polymer concrete. This polymer brick was made up of recycled plastic resin from plastic waste, recycled concrete aggregate for caustic aggregate, and baggage ash from side product of agriculture as a binder. These recycled materials doesn't reduce any strength of polymer brick because it doesn't affect the reaction of condensation polymerized in the polymer brick.
So the properties of polymer concrete depends on the polymer in concrete itself. For this topic, we are referring to a case study with the title The Polymer Brick as Nanotechnology. So polymer brick is a new material that reduces the use of cement. Also, cement in construction industry should be reduced because it will increase the emissions of carbon dioxide. According to Purwanto and Satyawati, the new material is made of plastic polymer waste as a raw aggregate and recycled concrete aggregate. So first, we look up to the properties, which is density. For polymer brick, the density is lightweight. This will greatly save construction budget because it will reduce the volume of concrete construction elements such as foundation, column, and beams. So for this case study, the addition of 10% nanotechnology in Bagasi ash will add compressive strength by 10%. In laboratory tests, it is found out that the additional nanotechnology will increase the compressive strength at about 10 to 57%. And the addition of Bagasi ash as a cement substitute with the portion of 15% in concrete can increase the compressive strength. Also, the compressive strength is directly proportional to aging concrete. In this study, researchers calculated the value of polymer brick conducted on acoustic laboratory. The average sound transmission loss of polymer brick is 53,908 decibel. It can be concluded that the polymer material can be applied as a new building brick material from its acoustical capabilities.
Design procedure. For polymer Raw aggregate was replaced with polymer on a volumetric basis. Baggage ash is used in place of cement in the composition of polymer brick. First, testing on compressive strength. The compressive strength of polymer brick tested with different volume of nanomaterial. The equation of compressive strength in the material is shown in the picture. Next, material density. The mixed design concrete technique is used in the design of lightweight concrete to get the specific gravity level on polymer and a concrete with a baggage edge. A composite of raw aggregate, fine aggregate and cement is used in this method. The density of polymer brick is determined as shown in the figure. Other than that, acoustical performance. The sound reduction function by a certain material is determined by the value of sound transmission loss (STL) of the material. STL is the ability of a material to reduce noise. The higher the value of STL, the better the material in reducing noise. Result and analysis. This is the result of compressive strength of polymer brick. Based on the table shown, the addition of 10% of nanotechnology in baggage ash will add compressive strength of 10%, while the addition of 20% of nanotechnology will add the compressive strength of 24.57%. Table shows the result of material density. The polymer that replaced the coarse aggregate will lose not only the weight of the concrete, but also the density of the concrete. Decreasing the weight of the concrete will be very beneficial to the construction of the work, because the lighter the concrete, the lighter the building construction. Next, acoustical performance. The output data from the impedance tube describe polymer material bricks has SPL about 48 decibel at frequency of 1000 Hz, then gradually rose to 50 decibel at middle to high frequency. From the data mentioned, it can be concluded that polymer material can be applied as a new building brick material from its acoustical capability.
Okay, now we go to discussion and conclusion. First, polymer concrete can be used in such various structures to improve the properties of structure itself, such as building which need to do waterproofing, such as swimming pool. And then polymer concrete also can develop sustainable of structure due to chemical resistance. For example, building which nearby to sea that we know contain high amount of sulfate, and then we can clearly see compressive and tensile strength of concrete will increase when we replace raw material with polymer substance, and then density of concrete also decrease when we replace coarse aggregate with polymer substance. The building also will experience lights in weight due to loss of porosity in concrete, and then we don't need to do compaction during placing of concrete. And due to reduce porosity in concrete, we also can see there is excellent bonding between steel reinforcement and concrete in order to make the building become more durability when load applied. As conclusion, polymer concrete is very useful to construction industry because it can improve the properties of structure itself, and also it reduce the emission of carbon dioxide to environment. Finally, it also can reduce the air pollution during production of ordinary Portland cement by replacing conventional concrete with polymer concrete.